Hello, guys. I'd like to take this time to explain to you the quiz we just did today. And for some of you who did not take this quiz, and the solution to this quiz should help you to understand the concepts. All right. We have these 6 questions on the quiz. Okay. What would we try to achieve by giving you a quiz like this? Okay. First of all, we covered domain and range for tangent and the domain range for arctangent. We did a graph. We studied the unit circle. We have studied the graph with lots of points plotted. So now everything comes together. Okay, so let's recap what we have learned. Okay, so for tangent. Okay, and what the domain for tangent? Domain for tangent is, okay, A can be any number, but what? But odd number multiples of pi over 2. So that's a domain. Okay, how about the range? How about the range? The range, as we understand, for tangent, the range is from negative infinity to positive infinity. So negative infinity to positive infinity. Arctan, okay, takes ratio, produces angle, right? We understand tan takes angle, produces ratio. So let's mark that. Okay, produces ratio. And what kind of ratio, right? That's related to our definition, ARD, right? It's the it's y over x. And of course, we need to specify ARD. We're going a little bit backward, okay? But let's just focus on, so suppose you guys know what is y, what is x, right? So x and y is described in the definition of ARD. X comma y is a point on the terminal side of an angle, which is A, right? Other than the origin. We have repetitively talking about this. And R is equal to the square root of x squared plus y squared. Very familiar concept with us. So the xy we talk about is, these two numbers. So we in our many lessons, we use the color tone. The y is the blue and the x is the red, right? So horizontal, vertical, and we have all of those concepts with us. Now, arctan takes ratio, okay, takes ratio, which is x, and produces angle. And what kind of angle? So we're going to describe it in the domain and range. The domain for arctan is all real numbers. And the range, right? We have lots of discussions about it. We did point by point, right? So now we summarize them and we're going to apply them. So the range is negative pi over 2 to pi over 2. You guys know the pictures. Okay? To enhance the understanding on the red and blue, we had pictures about that. Okay, the red and blue. So let's bring all of these things together. Okay, let's bring all of these things together. Red and blue. Okay, so I'm going to draw a piece of red and just some random examples. Okay, so that should be red. Okay, and that should be blue. And we just use this to describe, you know, what the situation is in the definition. And I'm just giving you a random example. So that's as a terminal. Okay, and you know, xy is any point on terminal side of the angle. So to make that description, and I can even, you know, make it like that. Whoops, what did I do? I think I did it at the wrong place. Okay, my bad. Okay, and the terminal can be written that way. Okay, all right, so red and blue, so we understand all of these situations. Okay, now cotangent. Okay, cotangent once again takes angle, produces ratio, right? Produces ratio, and what kind of ratio would that be? It's x over y, and which is red over blue. Red over blue. Okay, domain. The angle can be any real number, but multiples of pi. Okay, in these cases, k are integers, and the range will be from negative infinity to positive infinity. Arc cotangent, okay, arc cotangent takes ratio, okay, takes ratio, and ratio is x, produces angle. So the domain and range describe what kind of input it takes. Domain is all real numbers, and the range is, what is the range? The range is between 0 to pi. Okay, so of course we have more forms to write that, you know, range and so on and so forth. But here, and you clearly know the picture. We know the picture. Okay, and here we also have some shortcuts. So what are the shortcuts? Okay, let's see. Did we miss anything? Of course, you guys are not there, and I'm talking to a class without any students. Let's write down the shortcut. Right? We have derived the shortcut. We know where it came from. The shortcuts are 10 arctan of x equals to x. This piece is unconditional. Okay, this piece is unconditional from negative infinity to positive infinity. Okay, so that piece is unconditional. I'm going to put it in a box. Okay. Similarly, there's another unconditional piece. Okay, cotangent, arc cotangent, x equals to x, where x belongs to any real number. So the other one The other piece, okay, of composition is arctan of 10 of x equals to x. And this x must be greater than negative pi over 2, smaller than pi over 2. Okay, so this is the other perks, right? Shortcut. And one more, which is arc cotangent, cotangent x equals to x if x is between 0 and pi. So these are the shortcuts. These are the shortcuts. So we have all of these information, and we have the previous lessons to cover the how and why. So next we're going to use them. So the focus of this quiz is on how to apply these information to the situation, okay, including angle measurement, reference angle, etc., etc. Okay, so let's put back A and R. A is about angle measurement, right? Positive angle is measured counter clockwise from the standard position. Okay, and a negative angle, right? So a positive angle is measured counterclockwise. A negative angle is measured clockwise from the standard position, right? So one is the counterclockwise and the other one is clockwise. Reference angle is the positive acute angle between the terminal and x-axis. Okay, so we have all the information together. So now we're going to apply them. And in our current situation, we have unit circle, and all of these are special angles. Okay, all of these are special angles given. So let's do one by one. Okay. Okay, so you gather this information, you see which one would be applicable for you, right? Tangent of arctan, 10 of negative pi over 6, and then you realize which property applies. Well, this property applies because negative pi over 6 is between, it satisfies that condition. This is the condition for that statement to be true. Okay, and negative pi over 6 is in that interval. Therefore, the solution will be just negative pi over 6. And then you say, if I forget or I'm not sure, and there's another way to do it. So let me show you the other way to do it. Okay. The other way to do it is provided you forget about this terms, but you still know ARD and you still know the definition. You know ARD and you know the domain and range for these two functions. Okay, you still know the domain and range for these functions. Okay, you still know the domain for these functions. And what do we do? Right, so let's do the other way. Right, we still know these facts. So we're working on this piece. So what we can do, you just work it from inside out. How do you work it from inside out? Inside, tangent of negative pi over 6. And that's the part we're going to work first. How to work it out? you first need to measure negative pi over 6. How do we measure negative pi over 6? From standard position, clockwise. And here's the terminal. Here's the terminal. On this terminal, okay, we're doing tangent negative pi over 6. The blue number divided by the red number. The blue is y, the red is x. What you do here, you're going to do that division. The blue number is negative half. And the red number is √3 over 2. Okay, √3 over 2. Okay, that's the first step. And the next step, and then you simplify whatever's inside. And it's a negative number divided by positive number. So the quotient is going to be negative, right? And then you're going to multiply the top by 2, the bottom by 2. Okay, and then simplified. So you're going to have negative 1 on the top and and positive √3 on the bottom. And you rationalize it. You're going to multiply by 1. Oh, that 1 is specially designed. Is it going to be √3 over √3? That's 1. Anything times 1 stay the same. So in the end, not the end to this question, you're going to get negative 3 under √3. Okay. And then you're going to find the value for arctangent of negative √3 over 3. How do we find that value? Okay. When we are looking for the output for arctan, we know that quadrant 2 and quadrant 3 are no flight zone, out of the picture. So our angles is either measured from 0 to pi over 2, not equals to pi over 2, or from 0 to negative pi over 2, not equals to negative pi over 2. Right? That's what the range says. Okay? With that consideration, so which ratio will give us negative √3 over 3? Well, the blue divided by red is negative. So it has to be under, right? So all of these give you positive ratio, and all of these give us negative ratio. So negative √3 over 2, over 3, and that corresponds to negative half divided by √3 over 2. That terminal. So that terminal, that's right there. So now is from D to A, right? We know the ratio, we're looking for the angle. That angle has to be uniquely within this range between negative pi over 2 to pi over 2. And so we will only have negative pi over 6. Negative pi over 6. Okay, so this is the other way. All of these steps can be done differently. You can do it within, or you can do it on the side. Okay? Most of you show work like the following. Okay, so the next question is, how do I show my work? How do I show my work? You can show your work this way. You can show your work this way. You can also show your work in the following way. Okay, so you can remove all of these. When you remove all of that, and what do? If you need to figure out what is that ratio, and then you just do it on the side. You can do it on the side, okay? So this piece of work, on your scratch paper or not, right? You can just remove all of that okay? And you're calculating tangent of negative pi over 6, you can do your calculation this way. Okay, you can do your calculation this way. You guys with me? I hope you understand. Okay, so now you can, by doing this, you're basically moving the calculation just on the side. But don't insert in between. Don't insert in between. So you maintain the integrity of your work. You maintain the integrity of your work. Okay, nicely line up, right? Nicely line up like this, right? Most of you show your work like this, which is fine. It's perfect. Okay. But if you do tangent negative pi over 6 separately, make sure you express yourself properly. Okay. And of course, this piece is optional, but if you need to do that, do it right. Okay. So this is about the two most common way to do it. Number 2, arc cotangent. Arc cotangent is considered, right? So cotangent, arc cotangent, then of course you need to, we need to, we examine whether you know these facts. Domain range for cotangent, domain range for arc cotangent, okay? And do you know the shortcut? Do you know the shortcut, right? Can we apply the shortcut? Can we apply the shortcut in our case, right? The shortcut obviously requires, right? So this piece, okay, does not apply. If it doesn't apply, you actually don't need to mention. I put it here just to explain it to you. But for you, having this sentence is optional. Having this sentence is optional. You don't have to mention this sentence. And now, of course, you need to be aware of, you know, you want to have the unit circle right by your side. You want to know, the perk doesn't apply. So you also need to know these facts, domain and range, because that's what we're testing you guys on. Okay, no shortcut, right? So what do we do is that we're going to do it from inside out. So arc cotangent of negative pi over 6. Okay, how do you calculate cotangent negative pi over 6? Well, you first have to, you're gonna have to do ARD, right? So from ARD, measure the angle from standard position, negative pi over 6, and you have a point on the terminal side of the angle, and the cotangent of this angle, which is negative pi over 6, right? This is the angle, negative pi over 6. And this point is on the terminal side of the angle other than the origin. So cotangent of negative pi over 6 is x over y, which is red divided by blue, which is a red divided by blue. Okay, so here you're going to have the red is √3 over 2. And the blue is negative half. Negative half. Okay, oops, negative half. Okay, and then you simplify, right? You simplify the same way. You multiply, you can simplify this on the side on your scratch paper. Okay, but here I'm going to write it down, arc cotangent. Oops, arc cotangent of negative √3. Arc cotangent negative √3. Okay, arc cotangent negative √3. We have arc cotangent negative √3, and then we know the answer has to be between 0 to pi. Okay, arc cotangent value has to be between 0 to pi. So how do we find that? between 0 to pi, that tells us that quadrant 3 and quadrant 4 are not going to be, this is a no-fly zone. Okay, our angle can, the answer to the angle can only be found from ratio to angle. So which ratio, red over blue, will give us the, will give us the angle, the proper angle, right? So which one will give us that? -√3. So this piece, right? You will try, it's not possible you have all the ratios here on this side are positive, all the ratios on this side is negative. So, and you try all these numbers, this will give you -1, this will give you -√3/3, and this will give you -√3. So you would have identified the terminal that corresponds to -√3. That angle has a terminal like this. And how do we identify this angle? Identify this angle, you will measure that angle from standard position counterclockwise. Your angle can only be measured counterclockwise in this case, and that's -5 pi over 6. I hope that makes sense to you. Okay, so ARD, DRA. So first, inside cotangent -pi over 6, that's ARD. From -√3 to the angle, that's DRA. That's DRA, right? So your answer is going to be 5 pi over 6. 5 pi over 6. So we're doing this repetitively over and over, okay? How much work you need to show? How much work do we need to show? Well, you can skip this step, or you can keep it there, okay? Or you can insert one more step, or you can do like what we did earlier, just to separate it, okay? So for example, I can remove this piece, right? To keep it nice and clean, and put the rest part, right? So I'm going to put the cotangent -pi over 6 part over here. Okay, and then I'm simplifying it by multiply 2 on top, multiply 2 on the bottom, so I multiply by 1. Anything times 1 stay the same. Positive divide by negative. By this time, I got √3 on the top, and on the bottom is -1, right? √3 divided by -1 is going to be -√3. Okay, but make sure you don't insert this in between these lines. Keep the integrity of your work, this piece together. And you need to do something like this, put it on the side. Put it on the side. Don't insert them in between. What do I mean by that? Don't do this, okay, which I see very often. Okay, which I see this often. Sometimes people would do this here. Oh, sorry. They put this whole thing in between. And you have an equal sign here. I have a reason to take points off you. Why? Because you're telling me -√3 is the same as this piece. And 5 pi over 6 is the same as -pi over 3. Don't put it here. Okay, don't put it here. I would take points off if this happens again. Okay, it's not the right way to put it, to write it down. Write it this way. Okay, this equal sign tells that the latter is equal to the previous. The latter is equal to the previous. If you insert in between, it confuses the reader. It confuses the reader. And we are, the professor is very easily confused. Okay, very easily confused. So that's number 2. That's number 2. Now let's look at number 3. Number 3. Number 3, Well, let's see what are the perks we have. We have the perks here, we have the perks here, and we have, of course, the domain and range for tangent and arctangent. So we're gonna bring those information here with us, and we have the unit circle with us, right? And we also have the perks. Do you think the perk would apply? Well, because if the perk applies, that's going to be nice, right? But sometimes the perks don't apply. So I'm going to put the perks over here. Okay. Do you think that any one of the perks apply? Of course, the cotangent one doesn't apply, right? Not possible. For tangent, arctangent composition, the first one doesn't apply. The second one, maybe, no. Because negative 2 pi over 3 is outside negative pi over 2 to pi over 2. So this does not apply either. So I'm going to put the word here, but you don't have to. Okay, does not apply. If it doesn't apply, you don't even have to mention. Okay, I'm saying it here, it just to address you. Okay. You don't need to write it down. So this piece, this statement is optional. Optional. If you want to tell me, no problem. Okay, no need. No need to tell your other professors either. Okay, so we're gonna do it from inside out. Okay, inside out. What is tangent negative 2 pi over 3? Well, we're gonna measure the angle. Clockwise. Negative pi over 2 pi over 3. The terminal is right here, and we got a point. We got a point on the terminal side of the angle other than the origin sitting there waiting for us. And then we know how we're gonna it's tangent, right? So blue divide by red. So arctan, blue divide by red. The blue is negative √3 over 2. And the red is a negative half. You must make sure you don't get the order messed up. Okay? And then we know that equals to arctan, which is positive √3. Negative divided by negative is positive. And then we come to get arctan, which is arctan √3. You know the answer is only going to be between negative pi over 2 to pi over 2. Okay, what does that imply? It implies that quadrant 2 and quadrant 3 is not possible to be our terminal. Okay. Out, 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 out. Only between negative pi over 2 to pi over 2. So between negative pi over 2 and pi over 2, this is a positive ratio. So these will give you negative ratio. And where do we find that positive ratio, which is equal to √3? Blue divided by red. Blue divided by red, that give you √3 from D to A. Blue divided by red, which one? Well, it looks like it's gonna be this one, isn't it? √3 over 2, blue divided by red, 1/2 is gonna give you √3. Therefore, that angle, which is pi over 3, which is in the range for arctan, is going to be our answer. Pi over 3. Okay, pi over 3. So that's how we found it. That's how we found it. Okay, so continue on number 4. Cotangent, arc cotangent. Oops, what am I doing? There. Okay, number 4. Okay, number 4. Number 4, what information we need? Well, we need to know the perks. And of course, we know that among all the perks, this is not going to apply, and that's not going to apply. And which one of these two could possibly apply? Well, this is not going to apply at all. So the only possible one is this one, and apparently it doesn't apply. And we also need to be aware of the cotangent domain and range, right? The cotangent domain and range. And of course, we have our unit circle right there, right? There we go. We still measure negative 2 pi over 3. This is the second time we measure negative 2 pi over 3. We know where the terminal is. But this time, it's going to be red divided by blue by definition. Red divided by blue. So we got our cotangent and red divided by blue. Red divided by blue. So it's negative half. So never ever get these order mixed up. Okay. Negative √3 over 2. Have to do it by your own hands. Okay, so that's the cotangent negative 2 pi over 3 ratio. And now we simplify that. These numbers should be pretty familiar with us, right? Negative divided by negative is positive. So this is going to give us √3 over 3. Okay. If you have any issues, just put it on the side and simplify it. Then our cotangent, we're looking for the answer, and we know the answer has to be where? Has to be between 0 to pi. So quadrant 3 and quadrant 4 are outside this question. Okay, we don't need them. The answer has to be positive, less than pi. So which ratio, okay, these will give us a negative ratio, red divided by blue. And these will give us positive ratio. Which one give us the √3 divided by 3? Well, that's this ratio, right? This ratio will give us √3 divided by 3. Therefore, and we measure that angle that terminates right there on that point, and that angle is going to be pi over 3. Right? And that pi over 3 is indeed between 0 to pi, between 0 to pi. So we put the answer right there. Pi over 3. Right? The whole time we're doing ARD, DRA. Okay, ARD, DRA. So let's look at last two questions. Arc10 and 10 composition again. So what are we testing you? Same thing. We're testing you about the same thing. Okay, so I'm going to bring this all over again. Okay, we know these doesn't apply. This doesn't apply. And does this apply? Well, as a matter of fact, none of these two apply because it's negative 7 pi over 6, right? So none of the perks apply. Since none of these perks apply, the only thing we can use are these information. Okay, so we're going to do it step by step from inside out. Arc10, right? What is 10? Negative 7 pi over 6, ARD. We're going to measure from center position clockwise 7 pi over 6, and here's the terminal. Here's the terminal. Blue divided by red. Blue is positive, red is negative, right? So we're going to put in, and it's a half divided by negative √3 over 2. Right? Simplify. And we get arc10. And this negative, the positive divided by negative is going to be a negative. So put it in parentheses. And that's going to be root 3 over 3. Okay? Negative root 3 over 3, right there. Now we're looking for what angle would that be for negative root 3 over 3 over arctangent function? The answer has to be where? The answer has to be between negative pi over 2 to pi over 2, right here. And with that, we understand quadrant 2 and quadrant 3 are out once again. So which ratio? Negative ratio will give us an angle between negative pi over 2 to pi over 2. And these give us blue over red. That's going to be positive ratio. The negative ratio can only be found in the fourth quadrant. Which one will give us that? It looks like it's going to be this one, right? It's going to be this terminal from D to A. Negative half divided by root 3 over 2 is going to give us negative root 3 over 3. And how do we measure that angle? From standard position clockwise. And that's going to be negative pi over 6. Okay, that's going to be negative pi over 6. Oops. Negative pi over 6. You see, that's the whole process. We basically repeat the whole process over and over for different functions. And these information and the perks, when we can apply them, are the centerpiece. Okay, we practice on. Okay, so last but not least, so let's look at the last. Last, of course, is about cotangent and arc cotangent composition, right? So this time we're going to bring all of these with us to see which one will be useful for us. Okay, so let's leave enough space. Let's leave enough space. Okay. Does any one of the perk apply? It doesn't. Okay, the perk doesn't apply. Neither one applies. Okay, so we do it from arc, from inside out. Inside out. Measure the angle negative 7 pi over 6. Well, we already measured it. And the terminal, we know where the terminal is. The terminal is right here. Okay, but this time, to find that ratio for cotangent negative 7 pi over 6, we're going to take the red divided by blue. Definition, red divided by blue. Okay, red divided by blue. So what is the red? The red is negative root 3 over 2 divided by the blue, which is half. Okay, and this is going to give us arc cotangent, and that's going to be negative root 3. Negative root 3. Okay, and then arc cotangent is considered, and we know the answer can only be between 0 to pi. So because we know the answer can only be between 0 to pi, quadrant 3 and quadrant 4 are the no-fly zone. Out. Okay. And then you look at the ratio is negative. These are positive. These give red divided by blue give positive ratios, and red divided by blue give us negative ratios. Which one, red divided by blue, will give us negative root 3? Oh, wait. Okay. So I'm going to cross it out again. Okay. So which one will give us that terminal that would be negative root 3? D to A. So this is a D. So this terminal will give us cotangent ratio, which is negative root 3. And how do we measure the angle? From standard position counterclockwise. And that angle is going to be 5 pi over 6. And you want to know that this answer is going to be in the range, because if you get an answer that's outside the range, that is the wrong answer. That's the wrong answer. Okay, you can see in the whole process, we are keenly aware of the domain and range of the functions. We apply ARD sometimes, and then we apply DRA sometimes. Okay. All right, so that's the end of this recording. Thank you for watching. Until next time.